Hello and welcome to Uncle Math Online Academy. We have further mathematics now, and we want to talk about factor theorem and remainder theorem. This is a continuation of our lesson on polynomial and functions. Factor theorem is talking about the factors of polynomials. The factors of polynomials. And I believe you know what a factor is. A factor is something that you can multiply with maybe another number or another factor to give the original function or the original polynomial. When we simplify a polynomial, we get its factors. When you multiply the factors, you get back the main equation or the main polynomial. So it's from the factors of polynomials that we get their roots. Therefore, any value that satisfies as the factor of a polynomial, we have or can serve as the roots of the polynomial or function. For instance, if you have that x if you have that x plus 1 is a factor of a given polynomial, what it means is that if we put x equal to 1 equal to minus 1, from this you can get that x equal to minus 1. If you put x equal to minus 1 as a function, that is function of y when x equal to minus 1, if you put this into the polynomial, we are going to get 0. That is, from the factors, we get the zeros of a polynomial. While remainder theorem is talking about the values or the terms that remain after we've divided a polynomial with another term. When we divide a polynomial with any term or with any value, whatever remains after the division is a remainder. If you are given any term to divide a polynomial and you get a remainder, that value or that term cannot be a factor of the polynomial because it will not give 0. It cannot give a 0 of the polynomial. So this is the formal definition for factor theorem. Factor theorem states that x plus or minus n is the root factor or 0. Root factor is the root, factor or 0 of a polynomial. Or let me remove factor is the root or factor of a polynomial. That means that when we put the value, the f function of x, we are going to get 0. Like this one, if this is a polynomial that we have, for us to get the factors of this polynomial means for us to simplify this polynomial to get values or terms that when we multiply them, we are going to get this polynomial back. We simplify it to get values or terms that when we multiply the factors, we are going to get back this polynomial. So when we are given this kind of question, what we do is to simplify the polynomial. And how do we do that? We just solve it. This is a quadratic polynomial. A polynomial in the form of a quadratic equation. So we use our way of solving quadratic equation to solve it, and we get these terms. We are not looking for the roots. We are looking for factors, the things that when we multiply them, they are going to give us back the equation, the polynomial. So it is always something of this nature, x plus or minus n, where n is equal to a value or a number. Then x is the variable. So this is the answer. When we simplify the quadratic equation, this is what we are going to get. And when we multiply this thing, we are going to get back the original polynomial. So these are the two factors of the polynomial. The question can also come this way. Find if this factor, if this number or this term is a factor of this polynomial. How do we do it? When you are given a value or a term, a linear polynomial, this is a linear polynomial, a term like this, and you are asked to verify if it is a factor of a certain polynomial, what you do is that you get the root value from this, the x value. The x value of this term is x equal to 2. That is the x value of this term. So when you get the x value of this term, then you put it into the equation and see whether you get 0, because for factor theorem, fx will give us 0. That means now that when we put this into the equation and solve, we are going to get 0 if we put 2 into the equation. So we now have, if you have 2 into the equation, what we are going to have is 2 raised to power 2 minus 2, which is 4 minus 4, and that gives us 0. Since it gives us 0, then it means that x minus 2 is a true factor of the polynomial. Then for remainder theorem, the remainder theorem, normally when we divide a polynomial with another polynomial, sometimes we don't get 0. We get to some terms that we cannot divide further. That term becomes the remainder of that polynomial. We'll get a quotient and a term we cannot divide further by the divisor. What is remaining that time is the remainder of that polynomial. So we can verify if a number is actually a term, is actually a factor or not a factor of a polynomial by inserting the term into the polynomial. If it gives us 0, it means that it is a factor of the polynomial. If it does not give us 0, it means that there is a remainder, and whatever you have there is the remainder of that polynomial. For instance, what is the remainder when this polynomial is divided by x plus 2? Now what we do first is that we find the x value of this term. We look for the x value of this term, which is x equal to minus 2. Now having the x value of the term, we put it into the polynomial and see whether we are going to get 0. If we get 0, it is a factor of the polynomial. If we don't get 0, whatever we get is the remainder in the polynomial. So we now put x minus 2 into the polynomial. We have minus x raised to power 2 minus 2 minus 2, and that gives us 4 plus 2, and that's 4 plus 2 minus 2, that is 6 minus 2, and that is 4. Now that means that 4 is the remainder when we divide this polynomial by this term. We are going to get 4 as a remainder. We are going to get a factor. This is the factor. When we divide the polynomial by this term, what we are going to get is 4. So that is what the remainder theorem is talking about. Example 2. What is the remainder when this polynomial is divided by this term? When we insert the x value, which is now 2, we are going to get 0. That means that the remainder is 0. When the remainder of a polynomial, when the remainder is 0, then the term is acting as a factor of the polynomial. So what it means is that x minus 2 is a factor of this polynomial, like we've gotten before. So the remainder can be 0 or anything above 0. If it is 0, it is a 0 of the polynomial or a factor of the polynomial. But if it is not 0, then it is not a factor of the polynomial. So it can be 0, positive number, or negative number. So this is it about the remainder theorem. Now we just say small thing again about the 0 of polynomial. 0 of a polynomial is the same as saying that the root of a polynomial is the same thing as talking about the root of a polynomial. So when you are given a polynomial and asked to find the 0 of the polynomial, it simply means that you should simplify or factorize the polynomial to get its root. That is the answer. Factorize the polynomial given to you to get the root. The root of the polynomial is the 0 of the polynomial. Sometimes they will give you the roots and ask you to verify if they are the zeros of the polynomial. What it means is that you should put the root given to you into the polynomial to see if it will give you 0. If it gives you 0, it means that it is actually the true root of that polynomial, or 0 of the polynomial. But if you are not given the root and you are asked to find the root, the 0 of the polynomial, it simply means that you should factorize to get the root of the polynomial. So somebody telling you to find the 0 of a polynomial is the same as asking you to find the root of the polynomial. So that is it about factor theorem, remainder theorem, and a little thing about the zero of a polynomial.